So I'm going to do this one backwards for no good reason. So geometry problem at the very end. Let's see what they tell us. They tell us that angle A is 30 degrees. And I know you guys know your 30, 60, 90 patterns. I know you know them, okay? So 30 degrees, opposite is an x, long side is x root 3, hypotenuse is 2, so that's probably important. They tell us that A to D is 10. Sorry, that's supposed to be twice x. So if this hypotenuse, this 30, 60, 90 is 10, this has to be a 5. They also tell us that from here to here is 40, and they give us a formula for the area of the parallelogram. It's base times height, and you just figured out the height. So the area has to be the base of 40 times a 5, which is 200. Easy problem. Super duper easy. 20, we've got a circle. The two formulas that pop into my mind are S equals R theta, and area of a sector would be 1/2 R squared theta. And your task is to find both the area of the shaded sector and the length of the arc marked X, and it's supposed to be numbers that work out that you can do by hand. So we're going to have to do some conversion here. I need this. The disclaimer was these were radians. So I'm going to take my 36 degrees. I'm going to have to multiply it by pi over 180 degrees. Now 36 enters 185 times. 5 times 30 is 150. 5 times 6 is 30. 150 plus 30 is 180. So this ends up being pi over 5. Now I can use my two formulas. My arc length is going to be pi over 5 times the radius of the circle 5. So it's just pi. My area is going to be 1/2 of that 5 squared times pi over 5 because the angle is pi over 5. So this is going to be a 25 over a 2. Think about that. And then times pi over 5. We get 25 pi over 10, which will reduce both those by 5, right? 5 pi over 2. These are not hard problems. You can do these. Even Hayden Burris, if you'll do the stinking sheet, can do these. 19 is something I haven't done with you in a minute. This equation represents a circle. Complete the square to find the center and radius of the circle. So the first thing we're going to do is we're going to move C, and I'm just going to bump it over here, okay? 15 equals x squared plus 6x, leave a little space, plus y squared minus 12y, leave a little space. Now, I'm doing all of this because I know that standard form of a circle is x minus h squared plus y minus k squared, and I'm going to put the r squared on this side since it lines up with that. So what I have to do is I have to go through this really old process called completing the square. This is ancient. This is Babylonian. Our b term here is 6. We're going to take 6. We're going to cut it in half and get a 3. We're going to square that 3 and get a 9. And we're going to add it here. And for equality purposes, we're going to add it here. The reason I did that is because this now factors as x plus 3 times x plus 3, which is x plus 3 quantity squared. Here, I'm going to take half of a negative 12. I'm going to get a negative 6. I'm going to square that negative 6 and get 36. So I'm going to add it here, and for equality reasons, I'm going to add it here. I know Bryce doesn't like this idea of equality, but sorry, Bryce. All right, moving on. I did that because this piece factors as y minus 6 times y minus 6, which is y minus 6 quantity squared. The right-hand side, it doesn't work out to be something that's nice to work with in this example, but the right-hand side makes 60. So my center is at HK. It's at -3, +6. And notice how this lines up right there? The radius has to be the square root of 60, which you can simplify. 60 is 4 times 15, so you can say it's 2 root 15. 19 is not a hard question. It's not. 18, rewrite this guy as far as you can. I'm just trying to get you guys to use a conjugate. I have no idea what this one's going to look like. But the conjugate of 1 minus cosine of x is going to be 1 plus cosine of x. All right, down low, I'm just worried about these two. That becomes 1 minus cosine squared of x. Up top, not going to distribute. This one's kind of funky, I think. 1 minus cosine squared should be sine squared, right? So, look at that guy. That guy is 1 over sine. And we're multiplying it by 1 plus cosine of x over sine squared of x. So we end up with this funky thing. 1 plus cosine of x sitting over sine cubed of x. Now, can you do much with that? Yeah, not really. Not really at all. This becomes 1 over sine cubed of x plus cosine of x over sine cubed of x. And there's a couple of little things you could do to this. You could call it cosecant cubed of x, because that looks better. This guy right here can be thought of as cosine of x times 1 over sine cubed of x. So you could think of it as cosine of x cosecant cubed. And then I guess you could do a little factoring. But there's just not a lot to do with it. It wasn't the problem I thought it might be. I was just trying to get you guys using the conjugate here. I guess about as far as a person would want to take this one might be do a little factoring. Think of it as cosecant cubed of x times 1 plus cosine of x. That would be about as far as it's worth taking. It really would be. Wouldn't do anything else with it. All right, so then we have the simplification. This is the same as it was on your last quiz. I just put it in here again. I was telling Toby one way of doing it, and then I realized it's probably not the best way of doing it. Secant's 1 minus cosine of x. We're taking away sine times tangent, which is also sine over cosine, right? What's up, Mr. Nesbitt? Since both pieces are sitting over the cosine, we can combine them. You got some quizzes?
I do. She barely got very far. Didn't.
Well, I'm not going to let her finish that because I just uploaded a video on that. I mean, that's crazy.
I know.
Oh, she's got more than that done.
Oh, she just didn't put it on that. Oh, okay.
Yeah, I'll grade that.
Okay, and then
there's another quiz that I made that they can retake.
do you want me to set that over here?
Oh, this is fine.
Okay.
I'm not going to play this game anymore if we have all week to make up things. I can't do it. But there's a second version of the quiz if they don't like the grade, so I just upload a video on how to do the whole quiz.
Okay.
So I'll just grade those as they are. If they want the grade, they want the grade. If they don't, they don't. All right, sorry about the interruption. We are down to cosine squared over cosine of x, and this just reduces down to cosine of x. Have a good weekend, Mr. Nesbitt.
You too.
All right, 16, and I'll probably stop at 16 because 3 o'clock just passed. There's little formulas you can use. Think about the lower right-hand corner of your circle quiz is one of them, because I think the cosine of an angle is x over r, isn't it? And the sine of an angle is y over r. So use those guys to your benefit here. But if you're at 150 degrees, it seems to me that the ordered pair is negative root 3 over 2 and then positive 1/2. I'm pretty sure that's what it is. So it turns out that the cosine of the angle is is negative root 3 over 2, and it must equal x over 3. And you can just kind of cross multiply here. So 2x equals negative 3 root 3. And that would leave x being negative 3 root 3 over 2. And I've showed other ways of doing this too. Like I've told you, you literally just multiply by 3, and that's all that's doing. If you'll notice, we took the x value and we multiplied it by 3. To find the y value, we're going to take the y value and we're going to multiply it by 3. So it's going to be 3 halves. There's your ordered pair. Easy peasy lemon squeezy. Yeah, I'm going to stop here because I would really like to go home. It's Friday and we have a 3-day weekend. So I'll finish this up Tuesday morning, give you the sheet of paper. I'm sure you'll be happy to do it.